Okay, we're looking at an aquifer. Actually, we're looking at two aquifers. Aquifers are layers of sand, gravel, fractured rock that can transport water. And so this bottom area here is full of a porous gravel, means that there's lots of open spaces, and so this gravel can transport water. And up here we have a second aquifer, also porous gravel, so it can easily transport water. Between them, however, is this layer. It could be clay, it could be a very compact rock that is called an impermeable layer because it cannot transport water. And in fact, what it does is it blocks the motion of water from this aquifer down to this aquifer. Now, we've got two names for these. Since this aquifer is confined between an impermeable layer at the top and the bottom of the box, of course, which is another impermeable layer down here, this is called a confined aquifer because that water is stuck between two layers of impermeable material, so it can't move. However, up at the top, right up here, way up at the top, is an area that's open to the surface. This is common in mountainous areas where it has an area where it does receive water. This is called a recharge area. So what we're going to do is we're going to charge up this aquifer. We're going to pretend snow is falling, and now it's melting, and now we've got some runoff. And so what has happened is as runoff has occurred, it's gone into this impermeable, or into this permeable layer on the aquifer, has been carried to the bottom of the aquifer because the aquifer was completely empty. But now we see something new. We see an area where the pores between the rock is saturated, and we see this large area up here where the pores are still full of air. And so we call these two areas of the aquifer the zone of saturation down here and the zone of aeration up here. And the boundary between the two is called the water table. So now we're going to add a little bit more water to this because we want to watch what happens to wells. So I have a well down in this aquifer, and as water is added to it, here's the water table, and the level of the water in the well represents the water table. So I could drop something down into the well, maybe a line with a weight on it, or there are fancy things called piezometers that they can drop in there to see exactly how much water is in that well. Now here's something weird that happens with a confined aquifer. As I continue to add water, so we're recharging and this aquifer is getting really nice and full, and I'm going to fill it all the way up past, okay, now if you watch the water table, it's following the impermeable layer. And so right here is the water can't travel past the impermeable layer, so up here it's dry. But down here, here's the water table, so the water table has followed the impermeable layer. But the minute that it has a chance to escape, that water rises higher in the well. So it's higher than the actual water table. So this is called an artesian well. Now, I'm going to add water to this top unconfined aquifer. It's unconfined because it means it's not trapped between layers. And as rain falls on it, the whole thing can fill up, and so now I have a second water table. I have the water table in the impermeable, the confined aquifer. I have a second water table here. And if you look at the well in the confined aquifer is still following the height of the water table at its highest point. And so that well is actually lower than this well, which is sitting right at the water table, which right now is a lake. And so we get two different well heights depending on the aquifers and what kinds of layers lie between the aquifers, and you can see that we've got a whole bunch of different things that we can identify. Up here we have a zone of aeration where there is no water in the aquifer. Here is that boundary. There's the boundary on the lower aquifer, here's the boundary on the upper aquifer. Those boundaries are called water tables, and then underneath that, where all of the pore space is saturated with water, is called the permeated zone, the zone of permeation. Let me try that again. The zone of saturation. Then we've got an artesian well, which rises above the local water table, rises through it, and then I've got a second well. This is just a regular well that rises to the height of the local water table.